Assalamualaikum warahmatullahi wabarakatuh. So, in this video, we will be learning the volumes by cylindrical method or also known as shell method. Okay, first we will look at the cross section when it is parallel to the y-axis. Okay, let f and g be continuous functions on the interval a to b, and let R be the region that bounded by the functions of y equal to fx, y equal to gx, and also the lines x equal to a and x equal to b. Therefore, the volume V would be the multiplication of circumference with the height and also the thickness. Okay, 2 pi r refer to the circumference. Okay, and the height will be the cx and the thickness will be delta x. Okay, for example, if you look at this cylinder, okay, this is what we call the circumference. Okay, this is 2 pi r, and then we will multiply with the height, which written here in terms of cx because it is a function here, and then delta x will be the thickness of the cylinder itself. Okay, how many cylinders will it be in the figure? Okay, therefore, here the volume of the solid that is generated by revolving the region R about the y-axis is given by V equal to integrate from a to b 2 pi rx cx with respect to x. Okay, rx is the distance between the shaded region to or from the axis of revolution, and cx would be the height of the cylinder. For example, for this figure, if we draw the image for this shaded region, okay, this pada micro drawing, okay, this would be the cylinder that I meant. Okay, this is the R, radius of the cylinder, and this is the height, which remains the cx here. Okay, height. Okay, 2 pi r will be the circumference, which we calculate this part. Okay, circumference times the height would be the surface area for the lateral side of a cylinder. Okay, this would be the accumulation of all the cylinders, okay, in this figure for this diagram. And then this is what I mentioned earlier, 2 pi x, this is the cross section, okay, and cx is the height. Okay, delta x here refer to the thickness of the cylinders. That means from here the cylinder would be formed until here. Okay, this is the delta x. Okay, therefore we integrate from a to b, from the starting to the end of the delta x from the start. Okay, let's look at an example on, not example, but yeah, example of a figure that has been revolved. Okay, 3D. Let's say this is the shaded region. After it has been revolved, it will be looking like this. Okay, as you can see, in the center there is a cylinder, and there will be another cylinder too in the graph. Okay, that means it is an accumulation, summation of a lot of cylinders in this figure. Okay, let's look at an example of calculation. Okay, find the volume of the solid obtained when the shaded region here below is revolved about the y-axis. Okay, it is revolved about the y-axis here. Okay, from the axis of rotation, drag it to the shaded region. Let's say to here, this will be your radius r. Okay, to the start to the starting tip of the shaded region, and from one end of the shaded region to the other end of the shaded region, this will be your height. Okay, as you can see, the radius here is actually parallel to the x-axis. Okay, and then the height here is vertical. Okay, for cylindrical shell method, please refer to the height. Okay, when your height is vertical and then your r is parallel to the x-axis, that means automatically you know that your v should be 2 pi integrate r h here with respect to x, which means here should be the x1 and x2. Okay, as per this question, we actually don't have to determine the value of S1 and S2 because here we know that it starts at 0 and ends at 4. Okay, and let us determine the radius and height. Okay, R is equal to X because the radius changes according to the difference in X. Okay, that means delta X. Okay, let's say if we drag the line until here, this would be another radius and this would be the height. Okay, let's say we call it here as S1. This is the height, sorry, and here is S2. That means the radius will change with respect to X. That means the changes in X. That's why R equal to X. Let's say if you drag the line until here to draw the cylinder, this would be your R then, right? So that means it refers to the value of X. So radius R equal to X. And then next, height. Since it is vertical, obviously you need to do top minus bottom. Okay, so for this one, the top curve is y equal to root x, so root x minus the bottom function for the shaded region, which is x-axis, where it is also line y equal to 0. That's why here root x minus 0. Okay, root x minus 0 is equal to root x. Okay, next, substitute the radius and height in the formula. So V equal to 2 pi, integrate from 0 to 4, RH. So R equal to X and H equal to root of X with respect to X. Okay, simplifying this, we will have X power of 3 over 2. After simplify, please integrate. Okay, integrate X power of 3 over 2 would be X power of 5 over 2 over 5 over 2, which is 2 over 5, X power of 5 over 2. Substitute the value of the upper value minus the substitution of the lower, substitute the upper boundary, okay, minus the substitution of the lower boundary. Okay, remember to write 0 even though you get the value 0, okay, and the final answer should be this one, okay, 128 over 5 pi unit cube. You can also change it into decimal and you may also multiply the value that you obtain here with pi, okay. So, the common mistake will be forgot to multiply with 2 pi. Okay, don't do that. Remember to always multiply the answers that you get, the value that you get here with 2 pi. Okay, next question will be this one. This is the second example. Okay, find the volume of the solid generated by revolving the region here bounded by y equal to 2x squared and y equal to 2x plus 4 about x equal to negative 2. Okay, now we need to draw x equal to negative 2. Where is the line x equal to negative 2 then? Okay. Sorry. So let's say this is x equal to negative 1. So that means x equal to negative 2 is around here. Okay. This would be the line x equal to negative 2. Okay, here is x equal to negative 2. That means this is the axis of rotation. Okay. So now we want to draw the cylinder, right? So drag from the axis or line of rotation to the nearest shaded region. Okay, stop here. So this one will be your radius. Okay. From this end to the other end of the shaded region, this will be your height. Okay, and once again, the height is vertical. Okay, when your height is vertical, V is equal to 2 pi integrate RH with respect to X. Okay, refer to your height. Okay, this one should be the value of S1 and S2. Okay, since we need to use the cylindrical shell formula, that's why I did this. Okay, and then next, let's say if it is not given to you, the value for this intersection point, you may also find it by finding the intersection points like this. Okay, by equaling the two equations. Okay, the two equations for the functions. Okay, so right now, we need to determine the radius and height. Okay, what is the radius? Radius is from here to here. That means, let's say, if we drag it to the bottom, okay, the radius is actually parallel to the x-axis. That's why it will be in the terms of x. Okay, what is the distance from here to this axis of rotation? Okay, it will be right minus left, which is r equal to x minus the axis of rotation, -2. R equal to x plus 2. Okay, and the next one for height. Since it is vertical, it will be top minus bottom. Therefore, h equal to 2x plus 4 minus 2x squared. Okay, for the previous question, the r is equal to x because another reason. Okay, this is your r, right? Okay, that means from here to here. Okay, let's say we rewrite it as x. So that means this is r, the distance between the axis of rotation to the point that we don't denote. Okay, so r equal to here, let's say we name it as x minus the axis of rotation 0. So r is equal to x. Okay, but for the second question, it rotates at line x equal to -2. So to find the distance for a horizontal line, it would be right minus left. Okay, and here it will be r equal to x plus 2 and height is this. Okay, as written here. Okay, and plug in the formula v equal to 2 pi integrate from the intersection points -1 to 2, small value to the higher value. Okay, r x plus 2 multiply with h, 2x plus 4 minus 2x squared. And here you need to expand them. Okay, not long but quite long. Okay, multiply each of the terms. Okay, be careful when you expand the factors. Okay, the brackets. And simplifying, we will have this one, this function. Remember to simplify because it will make it easier for you to solve. Okay, and next integrate. It will be -2x squared, will be -2x cubed over 3. And here I have simplified. Actually, it is x squared over 2 to 1. So it will be 4x squared. Okay, and here is -x power of 4 over 2 because 2x power of 4 over 4, 212. Okay, it becomes this one, and plus 8x. And then substitute the value of the upper boundary minus the substitution of the lower boundary. And hence, we have the final answer. The volume will be 45 pi unit cube. Okay, that's all for the cross section parallel to the y-axis. Okay, in the next video, we'll look at another other example where the cross section is parallel to the x-axis. Okay, thank you class. Assalamualaikum.